What's this mean?
The second one has meaning?
Because we're going to find the number of bushels, right?
Yeah.
So the number of bushels, and then this is the profit based on those number of bushels.
Yeah.
This would be the profit on 10 bushels, and B of T, I mean, you could,
Or the
it
10
doesn't really
or 10
make sense.
profits or something.
Yeah, I don't know, that's weird. So it's certainly that one, okay? And we already have done that, so it's the profit. The profit, actually, isn't this the profit on that we'll make off of 10 trees? Right? Because isn't T 10?
Yeah.
So it's the profit we'll make on 10 trees.
Beautiful handwriting.
Isn't that beautiful? So now we're just going to evaluate this function. So this tells us to do what with the b in this function. This isn't really a composite function, but
You put the B in.
yeah, we put the b in for the p. Okay. And now we're going to do a composite function because every place we see a p, what do we do with the 3x plus 1? We replace it. So f of 3x plus 1 equals 2 times 3x plus 1 plus 3x plus 1 squared. So it's okay to leave it like this, but sometimes they want you to clean it up. So in order to clean this up, what are we going to do?
6x plus 2.
Yeah, so 6x plus 2. And then we're going to FOIL this.
9x squared.
So plus 9x squared.
Plus 1.
Yeah, you got to FOIL it, young lady. 3x plus 1 times 3x plus 1. Right? You aren't the first person to fall for that. I have fallen for it before myself.
I'm always so bad.
So 3x times 1 plus 3x times 1 is 6x plus 1 for the last, and then combine like terms, right?
So it's 3x squared plus 6x plus 1?
It's 9x squared.
9x
Yeah,
squared.
plus 12x, isn't it?
What? Okay.
Because 3x times 3x is 9x squared, right?
Oh, yeah. 9x squared. And 3x. Okay, so 9x squared plus 6x plus 1?
Plus 12x plus,
Where are you getting 12x?
because I got to add, oh, I see. But here you're talking about, Amelia. Yeah, so it's
Yeah.
9x squared plus 6x plus 1.
Okay.
And then I'm combining like terms. So there's only one 9x squared, but then I get a 6x and a 6x, and it's 12x plus 3. Okay, messy. Nobody says we have to do anything more than this, but sometimes it's easier to.
Okay, I get that one.
Okay? How about this f of the square root of p? Yeah, we're going to do 2 times the square root of p. That's what p is now. Minus the square root of p squared, which does a little cleaning up. Isn't that 2 square root of p minus p? Which has implications later on.
Aren't we supposed to subtract the last one? Because we added those two together. Weren't we supposed to subtract that? Not to totally get us off while we're wrong.
Back here, Amelia?
Yeah. Weren't we supposed to subtract?
Ah, you're right. I'm wrong. You're right. Yeah.
Yeah, I was gonna say something, but then I was like,
You always call me on that. I make mistakes. So that's going to
But
become,
that
let me
was
change ink. So that's minus, that's minus, that's minus. So that's going to be minus 9x squared, and the 6x's cancel off. And so 9x plus 1.
Well, the plus 6x plus 1 is still.
That's still positive, right?
Yeah.
Right.
So it's.
Okay. So what do we do?
You find g of p first, I think.
F of g of p and g of f of p. So here, right, g of p gets dropped in to the f function, right? So here's the f function. This goes in, so if you think about the boxes, right?
When you put the g of p into the g.
Our f, let's see.
I don't
Our
like this.
f function, the notation's a little strange. Here's our f function, which is square root of something, right? So we're now dropping in the g function, right? Because that's the inside function, which is 1 over p. So it goes inside that f function. What do I write?
I'm
Square
trying
root of 1 over p.
to draw a pretty box.
Now you don't have to draw a box, but okay. When we're taking the square root of fraction, what can we do?
Wait, sorry, when we're doing what?
When we're taking the square root of a fraction like we are,
Mm-hmm.
how can we clean that up a little bit? What can we do? Sometimes it doesn't clean up. This one does.
You can square out the number.
Yeah, I can take the square root of the top and the square root of the bottom. So that could be 1 over the square root of p, and we could leave that alone. Should rationalize, but we aren't going to worry about that. So that's the first part.
So it's g of p, or f of g of
F,
p.
yeah, it's f of g of p.
What are you watching in there, Drew?
The ultimate gift. It's really good.
And then we're going to do,
What his grandfather left from for as well. But they have like.
so now what do we do? What do we do with the next one?
We dropped into that other one.
And we drop the square root function into the 1 over p function, right? So 1 over the square root of p. Look at that, it's exactly the same. That's interesting. Doesn't always work that way.
Is that
Now what they want to do with this page is they want us to break this complicated looking composite function up into 2 separate functions. So when I do this, I take a look, I see how you get this cube root. I look at what's underneath that, and I think that's the inside function. So I would write this out as 4 cube roots of x minus 2. That would be the f function, the outside. And then the inside function, I'd think of just as x squared plus 5. See how that works? The stuff in the book, the exercises in the book aren't quite as complicated as this.
That actually makes sense.
But that does make sense or doesn't?
Because it's the stuff that's under the cube
Right,
root,
it's what's
so
underneath the
that's
cube
f.
root. That's going to be our inside function.
Okay.
See the inside function.
Mhm.
Okay? So what, I gave these 2 functions. What's the f of g of x? What's the inside function?
So wait, what are you trying to do?
I want to find f of g of x.
Okay. So put f of x into g of x.
G into f, right?
G.
G is the inside.
Okay.
so would it be the square root of
2.
1?
Yeah, it'd be 2. Aren't we dropping g into f for this one? We're dropping g inside of f. So we're going to take that part and drop it in here. So won't that just be 2 over that?
2 over the square root of 1
The
minus x.
square root of 1 minus x.
So
So let's
2
talk about
over
domain.
1, the square root of x. Would you simplify it to that or just keep it there?
No, you can't simplify that anymore, right? Because you can't take the square root of a difference. I can't take the square root of 3 minus 1, right? If I took the square root of 3, minus 1, which you were talking about doing, because this is the square root of 2, right, if I do it right. Okay, so don't take square roots of sums or differences. Products you can. What's the domain issues here? Remember, I can't divide by 0. Whoops. And I can't take the square root of a negative number. So when is this equal to 0? The denominator. When x equals 1. All right, so when x equals 1, that's a problem. So and x can't be less than 1, can it? Well, actually, x can't be bigger than 1. Right, it can't be 2, because that would give me the square root of negative 1. So x has to be less than positive 1. It could be 0, right? If x was 0, that works. If x was 1/2, so x also has to be less than 1.
Yeah, but it can be greater than 1 as well.
Well, if it was greater than 1, it would be 1 minus 3, say. What's the square root of 1 minus 3?
I do too.
Yeah,
Gotcha.
okay? Whoops. Whoops, 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 I don't want to do that. Well, let me erase? No. So, we could leave it like this. Probably want to write interval notation. So, negative infinity to 1, right? But it can't include 1.
Hard bracket. Right?
No, close open bracket, because it can't include 1. How about g of f of x? So what do we drop?
You drop 2 over x into. No, never mind.
The square root of 1.
I'm sorry, I'm distracted. Whatever's beeping.
It's the
I think it's
Is
the
in the
movie.
movie?
Yeah.
Oh.
I think you do the square root of 1 minus x.
Yep. So 1 minus 2 over x, right? And we aren't going to try to clean that up today. Can x be 0?
No.
No. So it doesn't include 0. And then we got to ask ourselves, when does 1 minus 2 over x, I can't be negative, right? So how do I solve that equation or inequality?
X is a positive number. Is greater than 1 or
Yeah,
greater.
so I'm going to do this. I'm going to add root 2 over x to both sides. And then I'm going to solve this for x. So I'm going
I
to
was just say that.
cross multiply. What? You just going to say that? It's good.
I don't.
Okay, so it's got to be bigger than 0, but it also has to be bigger than 2. So that's the more limiting thing. So we're going to say the domain is 2 to infinity. Can it be equal to 2?
No.
No. Just 2 over 2. 1 minus 2 over 2 is 0. Can I take the square root of 0?
No.
I can't take the square root of 0?
Yes, you can.
Yes, I can.
Yeah, it's
So
0.
that's a hard bracket for the 2. Because it can be 2.
Yeah, but even though you can take the square root of 0, you can't have the 0 in the
X can't,
denominator.
right, but I'm not saying x is 2, right?
Yeah.
X is 2. Just so happens y is 0 and x is 2.
Okay.
Okay?
Gotcha.
Whew, how are we doing for time, guys? 3 minutes? You had enough?
Yes.
So, do some of the online stuff. Have you started one for?
No, because my internet went out.
Well, you can start doing some of the 1-4, at least the graphs and the tables.
Okay.
And we'll come in tomorrow and finish this up. And so hope that helps.